discussed detectors earlier. Let's look at it now on the instrument. So here I have the two detectors I discussed, the deuterated L-alanine triglycine sulfate, DTGS, which is the one I've selected first, and I also have a mercury cadmium telluride. You can see here that this is the interferogram coming live off of the instrument, and I've got about 9.5 volts of signal. I mentioned that DTGS detector detecting heat has a slow response. If we were just to increase the velocity of the mirror, you'll see the effect of that. Remember, it's about 9.5, now it's 4.5 volts just by increasing the velocity that little bit. If I increase it even more, the intensity of that interferogram will continue to drop. So the DTGS likes it when you scan more slowly, and once you do that, it's a less expensive detector and it's very, very linear. So it gives you a good response over a wide range of absorptions. Now let's change, without changing anything else, we'll change over to the mercury cadmium telluride detector. The first thing you'll see is that the signal is going to be enormous. See, it's 22 volts up here. This is because the MCT is so much more sensitive than the DTGS. So we're going to have to tune it down a bit, and what I'm going to do is put a screen in the way, basically a screen with holes in it that cuts down the light going through. And you see now I'm down to about 12.25 volts of signal, so I brought it down with that screen. Now the MCT is a photon counter, a quantum detector. It counts very much more rapidly. So as I change the scan speed here from the 1898, which is the standard speed for the MCT, and I run it up to a higher speed, notice the voltage doesn't change very much. It's still 12.3. If I slow it down, I don't get a big benefit from it either. It's going to be about 12.5 volts. There's not much change depending upon the speed with which you're scanning when you're using this quantum detector. So that's the comparison of the two. DTGS, linear, slow, inexpensive, very reliable. The MCT is much more highly sensitive, requires the liquid nitrogen cooling or cryogenic cooling, is not sensitive to the speed. So as you change the speed, you get the same sort of response. So that kind of gives you an idea of how to pick which detector you want depending upon your experiment.